A racing car traveling with a constant acceleration increases its speed from 5 meters per second to 45 meters per second over a distance of 50 meters. How long does this take? So we can solve this relatively easily with the use of kinematic equations. So if you recall, we had four main kinematic equations. Those were the final velocity is equal to the initial velocity plus the acceleration times a time interval. You have that the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the displacement. The displacement is equal to the initial velocity times the time plus 1/2 times the acceleration times the time interval squared, and that the displacement is equal to the initial velocity plus the final velocity divided by 2 times the time interval. And these are the four basic kinematic equations that we can use for this equation. Now we just need to figure out which one of these to use. So we need to solve for the time. So any equation that does not have a time, we do not really need to use unless we're taking 2 steps to solve this problem. Also, right now we don't know the acceleration yet, since we don't know the acceleration over this time period, over this distance over here. So we can get rid of both of these equations because the acceleration, we don't know the acceleration for any of these. So this leaves us with this final equation right here. So I'm going to clear things up a little. The equation that we're going to use says that the displacement is equal to the average of the initial and final velocities times the time interval. And this question is asking us how long it takes, so we are looking for the time interval, the time that it takes. So we can just simply solve for the time over here. So all we need to do is solve for the time, and you find that the time is equal to 2 times the displacement divided by the sum of the initial and the final velocities. So now all we need to do is just plug everything in. The time is equal to 2 times the displacement of 50 meters divided by the sum of the initial and final velocities of 5 and 45 respectively. So this just becomes 2 times 50 divided by 50, and these two cancel out, so you just get that the time it takes is just simply 2 seconds. And that is how you would solve this problem here.